Good morning, my dear students. My name is Andrej Sharma, working as physics lecturer in one of the reputed institution. Today we are going to know a very important concept for all competitive exams, that is Gauss law. Okay? Today concept is about Gauss law. So before going to know about Gauss law, we'll take one example. Suppose there are 2-point charges, say Q1, Q2, okay, separated by a distance R. Then using Coulomb's law, you can find the force between them. Okay, but imagine that the 2-point charges are started moving. Okay, so whenever charge is moving, then followed by it will produce a magnetic field. You must have studied in electromagnetism. Flow of current produces magnetic field. Now in such cases, when charge is moving, force is due to electric and also due to magnetic, right? So we cannot use Coulomb's law, because what is limitation of Coulomb's law? Whenever 2-point charges are at rest, you can find force between them. No, but whenever charge is moving, followed by it will produce magnetic field also in such complicated cases. So this varying electric and magnetic fields, we are finding electric field strength due to Gauss law. Okay, so in order to know about Gauss law, let us take one example. Suppose there is one point charge. Q is charge on it. Okay, so you want to find field strength due to this point charge. Okay, or electric flux which is coming out from this point charge. How? Very simple. So Gauss given a technique to find flux through a charged body. How? That is, according to him, the charged body must be surrounded by a Gaussian surface. So it is spherical body, no? So it can be surrounded by sphere. No? So the charged body is surrounded by sphere. Now you can find field strength on this Gaussian surface or on the charged body, or flux which is coming out through the charged body also we can find. How? So this is a given problem. There is one charged body, spherical in shape, of radius R, Q, charge on it. So now you want to find flux which is coming out through this charged body, or field strength due to this charged body. In order to solve such problems, it must be surrounded by a surface. So it is nothing but Gaussian surface. So radius of this be capital R. Okay. Now you want to find at this point, say surface area of this is ds. So flux due to this small surface, flux which is coming out through this small surface is d phi is equal to, okay, E bar dot ds bar. No, nothing but E ds cos 0, because electric field strength surface are in the same direction, so angle between them 0, cos 0 value 1, so it is EDS is d phi. But you want to find the total flux due to this total flux. Okay, so you have to integrate now on both the sides. So integral d phi is phi na E at a point. How you calculate E at a point? E equal to 1 by 4 pi epsilon naught Q into here 1 na, so force between 2 point charges, that is force experienced by unit point charge, right? So that is why 1 by 4 pi epsilon naught, okay, into Q by distance r square into ds. Now, so flux is equal to 1 by 4 pi epsilon naught, right? Q by r square you can take outside. So only integral ds. Now integral ds equal to s na, means surface area of this sphere 4 pi r square, right? 4 pi r square cancelled. You get Q by epsilon naught. So what is Gauss law statement? The total electrical flux through a surface. Now, so total electrical flux through a closed surface is always equal to 1 by epsilon naught times of charge enclosed in that surface. That is, pi is equal to Q by epsilon naught. Or you can also write line integral EDS equal to Q by epsilon naught. Okay, so that is Gauss law. Now using Gauss law we are going to calculate now field strength due to a long thin charged wire, infinitely charged wire. Okay. So I have taken a long, thin, uniform charged wire, okay, of density, linear density lambda. How you define linear density? You know, charge by length. Okay? So our aim is to find field strength. Okay? What is the name of this derivation? Field strength due to long or infinitely charged thin wire. Okay? So field due to long straight charged wire. Okay? So this is the long one. Okay? So you want to find field strength due to this. So what we supposed to do? It must be surrounded by a Gaussian surface. So remember, whenever you want to find field strength, the charged body must be surrounded by a Gaussian surface. Okay? So here I am taking a cylindrical surface. So it is surrounded by a cylindrical surface of radius r. Okay? Length n. Okay? Its linear charge density. Okay? Linear charge density taken as lambda. That is, you know, Q by L. Okay? So according to Gauss law, you need to find the line integration of three surfaces. Two flat surfaces and one curved surface. No? So flux is equal to line integral of EDS 1 plus line integral of EDS2 plus line integral of EDS3, which is equal to, according to Gauss law, Q by epsilon naught. But if you notice, this surface 1 and surface 2 are perpendicular to the conductor. No? This surface and this surface are perpendicular. Whenever two vectors are perpendicular, their dot product is always 0 now. So that is why surface 1 plus surface 2. This one. Line integral, this product 0. This product is also 0. Why? Surface perpendicular to conductor. Okay. Now only one surface is left. Nothing but curved surface. So line integral of EDS3, okay, is equal to Q by epsilon naught. So the curved surface area of cylinder, it is 2 pi r into L now. So here the Gaussian surface radius r, length L. Okay, so that is equal to Q by epsilon naught. Lambda taken as linear charge density, right? So lambda is equal to Q by L now. Then Q becomes lambda L by epsilon naught, right? So L cancelled. Then E, strength of electric field, due to this thin, long, uniformly charged wire is lambda by 2 pi r epsilon naught. Okay, so this is the field strength, due to this long, infinitely charged wire. Okay, now we'll discuss about the second one. Now we are considering a infinitely charged sheet. Okay, so there is one charge sheet. Okay, we want to find field strength due to this charged sheet. Okay, this one. Okay, so in order to find flux or field strength, it should be surrounded. Otherwise, we insert a Gaussian surface. So here I am inserting a cylindrical surface into it of radius r. Okay, now field strength, okay, due to infinitely charged sheet. Okay, so we are now taking a charge sheet. Okay, now you want to first find flux through this, right? So there are three surfaces now. In this case also 1, 2, 3. So total 3 surfaces are there to integrate. Line integral EDS1 plus line integral EDS2 plus line integral EDS3, which is equal to, according to Gauss law, Q by epsilon naught. Okay, so let us consider sigma be the surface charge density. Okay, so what is sigma? Surface charge density. That means charge by surface area. Okay. Now, if you notice, this charge sheet is only perpendicular to Gaussian surface, but the other two circular surfaces, now this one and this one are parallel. No, this one and this one, but this is only perpendicular. No, so flux is equal to surface 1. Okay, so line integral EDS plus second one line integral EDS 2, but both are having same surface. Okay, same surface, plus last one 0. Why? Because you know this surface is perpendicular to Gaussian. No, so this is 0. Okay, so you know 2ES equal to Q by epsilon naught. But you know line integral of ds gives s now, so that is why it will become 2ES equal to Q can also be replaced sigma s now by epsilon naught. Okay, so Q I am taking sigma s, thereby you know s is cancelled, right? You get field strength, okay, is equal to sigma by 2 epsilon naught. Okay, so this is a field strength due to a infinitely charged sheet. Okay, using Gauss law. So remember, whenever you want to find flux or field strength, first the charged body must be surrounded by a Gaussian surface, right? Next, now we are going to know a charged sphere also. Okay, field due to charged sphere. So let us suppose you have taken a charged sphere and you want to find field strength due to this charged sphere on the Gaussian surface, on the charged body and inside the charged body. Okay. So this is the charged sphere, okay, of radius r. So the Gaussian surface, okay, of radius capital R. Okay, so you want to find field on the Gaussian surface, okay, and on the charged body and inside the charged body. Okay, first we'll consider on the Gaussian surface. You know, electrical flux is equal to line integral EDS. You know, in order to find flux, it must be surrounded. So it is spherical body, no? So it is surrounded by sphere only, right? So equal to, you know, Q by epsilon naught according to Gauss law. Okay, now E line integral of ds, okay, equal to Q by epsilon naught. You know, surface area of this is 4 pi r square, right? So E into 4 pi r square equal to Q by epsilon naught. Then you know E becomes Q by 4 pi r square, right, into epsilon naught. So this is the electric field strength on the Gaussian surface. Suppose you want to take on the charged body, okay, on the charged body. Now distance is R na, same charge body but distance is R. So that is why field strength, okay, at point Q will become 1 by 4 pi epsilon naught Q by R square, right? But suppose you want to find inside, okay, inside there is no charge now, so that is why electric field strength will become 0. And one more point also revealed out under this derivation, that is, this is nothing but Coulomb's law na? So Coulomb's law can also be derived through Gauss law. Okay, so followed by this we'll do charge body taken at center of the cube, one side of the cube and one edge of the cube. Okay, let us consider there is one charge body Q placed at center of a cube. Suppose you have given a question, find flux through each face of the cube. Okay, that is your question. How? Very simple. According to Gauss law, total flux linked is equal to, right, charge enclosed, no, by epsilon naught. So this is the total electrical flux. Okay, but you want to find flux through only one face of the cube. Okay, so how to solve these Gauss related problems. That is, first charge must be surrounded by a Gaussian surface. Here the charge body is at center now, so you need not surround it, is already at center. So this is having 6 faces, right? So 6 into flux through each face is total na, equal to Q by epsilon naught. Therefore flux, right, through each face is equal to, okay, total charge enclosed by 6 epsilon naught. So this is the electrical flux through one surface of the cube. So why I have taken 6 over here? Because cube is having 6 faces, right? 1, 2, 3, 4, 5, bottom 6, right? So that is why flux through each face will become Q by 6 epsilon naught. Now let us assume there is one charge body. Instead of center, say it is placed at center of the one face of the cube, like this. Okay, so this is your problem. Okay, so you want to find flux of this cube, given cube. How? It is very simple. It must be surrounded, right? So how you can surround? Only through another cube, like this. No? So whenever it is surrounded through another cube now, you can find the total flux, right? So total flux of the system, that is when it is covered with another cube, is charge enclosed by epsilon naught na. So you want to find through only one cube. No, it can be closed by another cube. So this is taken as Gaussian surface. No, you are covering this through another cube. So total how many cubes are there? 2, right? So flux through given cube is equal to, you can say, charge enclosed, right, by 2 epsilon naught. Now Q epsilon naught plus Q epsilon naught. Why? Because this is your given problem. There is one charge body placed at center of the face of the cube. You want to know flux of the given cube. So in order to find the flux it must be surrounded by a Gaussian surface. No? So that is why you are taking total 2 cubes. No? So through 1 cube, Q enclosed by 2 epsilon naught. Right? Now we'll discuss about another problem. Now, suppose there is one charged body Q placed at one corner of a cube. Okay, this is one charged body placed at one corner of a cube. Okay, so you want to find the flux of the given system. Okay, so you want to find flux of the given system. You know, you can find flux only, it should be surrounded by Gaussian surface, right? So what we are doing, so we are surrounding this charged body. Okay, you can take like this. No? So you know, it is totally surrounded by 8 cubes. The charge is at center, it should be surrounded now. So that is why, you know, you are covering with total 8 cubes. See, first already you know one is there. No? So it is surrounded by total 8 cubes. Okay, so the charged body is surrounded by 8 cubes. No? So you know, according to Gauss law, total flux of this system is charge enclosed by epsilon naught, right? But here the total cubes you have taken is 8, right? So 8 into flux of each cube, no? Flux through each cube is equal to, you know, charge enclosed, right? By epsilon naught. So the given question is flux through one cube. Now, means given cube is Q by 8 epsilon naught. Right? So in this way, whenever you want to find the flux, it should be surrounded by a Gaussian surface. So followed by it, you can find flux easily. So if you like this video, please like, share, subscribe. Thank you for watching this video.